Hi everyone, welcome back to Mind Maths with Amina. Today I'm going to continue my lecture on solving the sample examination questions given in chapter 2 called Basics in the Mathematics 1 study guide given by University of London, London School of Economics. The first question is the demand equation for a good is given by this equation. This is the inverse demand function. Price dependent on quantity is q square plus 6q plus 24. Sketch the demand curve for q is greater than equals to 0. If the supply curve is this, so this was the demand curve, and the supply curve is minus q square minus 8q plus 180. Determine the equilibrium price and quantity. So they only need us to sketch the demand curve, and they want us to find the equilibrium quantity and price. Okay, remember, in order to sketch a curve, the first step is to find the intercepts. So that's always step 1. So the q-intercept is all points where p is equals to 0. So when we take p is equals to 0, we end up with this quadratic equation. You can either find out the roots by factorization, or you could do completing the square, or you could just use the quadratic formula minus b plus minus b square, which is a 36 minus 4ac over 2a. As you can see, this is going to be a negative number, so therefore the roots are actually of complex nature, so they don't in the xy plane as in not the complex plane, there are no roots, so this is undefined. What about the p-intercept? P-intercept is all points where q is equals to 0, and we can see that easily that's going to be a 24. So 0 and 24. Now that we found the intercepts, we need to find the critical point. For the critical point and its classification, we are going to take the derivative and the double derivative. However, in chapter 2, we haven't covered derivatives yet, so we are just going to use the completing square method. So we're going to end up with having to do the completing square. So p is equals to q square plus 6q. 6 divided by 2 is a 3. So plus 3 square minus 3 square plus a 24. So therefore we have q plus 3 square, when there's a 1 here, and minus 9 plus 24. So if it was a minus 10, we would have had a 14, right? So it's going to be a 15. So since 1 is greater than 0, this means that we have a minimum point. And the critical point itself is, the critical point is minus 3 and a 5. Sorry, a 15. Sorry, I got interrupted. Anyhow, so let's sketch this. Minus 3 and a 15 being the minimum point, and 24. I'm not drawing this to scale, as you can see. So it looks something like this. Yeah. So since we had to draw the part only for, okay, we have the azan happening and I'm outdoors, so I'm going to pause the video right here. Okay, so we can continue. The azan stopped. Okay, so they asked us to draw the diagram specifically just for positive quantities. So this is the diagram which we were supposed to draw. So let's just erase this then. Or I'll just keep it here. I forget I'm not using paper, so it's fine to just use as much space as I want. Okay, so that's the demand curve for positive quantities and positive prices. PD as a function of Q. Next, we were asked to find the equilibrium price and quantity, and thank God we weren't expected to sketch the supply curve or show the equilibrium point diagrammatically. So solving for the equilibrium price quantity is very easy, because all you have to do is just solve these two equations simultaneously. So let me solve this simultaneously. Since we have a point of intersection, that means that the price and quantity at this point is going to be same. So therefore, at equilibrium, price demanded is equals to price supplied, and also quantity demanded is equals to quantity supplied. Okay, so we have a 2q square plus 8, 9, 10, 11, 12, 13, 14, 14q, and then minus 156 is equals to 0. I hope I got that right. 24, yeah. It's gonna be a 6 here. Yeah. I should probably get my calculator out, because my mental math sucks. Okay. Q is equals to minus b plus minus b square minus 4ac over 2a. Okay. According to the calculator, when we solve this, we're going to end up with, we're gonna get a q is equals to minus 13, which is negative, so that's invalid. And the other quantity is going to come out as 6. This is a valid quantity. And the correspond, so this is the equilibrium quantity, and equilibrium price would be, you can substitute this into any of the equations, either the supply or the demand. I'm putting it into the demand equation. So a 6 square plus 6 square again plus 24, and this gives us a 96. So the equilibrium point, quantity and price is equals to 6 and 96. So we can basically imagine a supply curve cutting like this at quantity 6 and price 96. Yeah, so that's the equilibrium. And we had another sample examination question, and I believe 3 examination questions. Okay. The second examination question is, let f and g be functions given by this and this. Show that the graphs of the function f and g do not intersect. Since I think we can show this without actually drawing them. So let's just show that there is no point of intersection. So let's try to show that if we try to find a point of intersection, there is not going to be any valid solution. So if they had a point of intersection, then we would have been able to solve them simultaneously and obtained a valid solution for x. So, but if there's no point of intersection, then we'll try to solve this simultaneously, but we actually will not end up with any valid solution. So we're going to be left with x squared plus 2x plus a 5 is equals to a 0, and let's see, minus b plus minus b square minus 4ac over 2a, right? And as you can see, we have a negative number, 5 4s are 20 and a minus 16. So therefore the determinant is the discriminant actually is a negative number. So the solution is going to be a complex number. So a 4i over 2. And remember that this is not actually, this actually takes us into the complex plane, and that's not a valid solution. So this basically means that we have an invalid solution because the discriminant b squared minus 4ac is negative. So it's invalid. Hence, it means that we do not actually have any point of intersection. Hence, no point of intersection. Okay, so we've done part A. Next, they want us to sketch the graphs of both the functions on the same diagram. And for part C, for a constant C, let h be the function this. Find the values of C for which the graphs of f and g will intersect. Okay, so we start by sketching them. So this is a very typical question. This was the function for fx. Let me just copy paste it down. So let's start off by sketching fx. Okay. Remember, step 1 is always finding the intercepts, right? So we can just write this as y. Okay. So when x is equals to a 0, y is equals to a 2. So the y intercept is a 0, 2. And when y is equals to 0, 2x squared plus 4x plus 2 is equals to a 0. And we are left with x squared plus 2x plus 1 is equals to a 0. X squared plus x plus x plus 1 is equals to a 0. X is equals to x plus 1 plus 1 x plus 1. So therefore x plus 1 whole square, and therefore we have just one intercept. So it's going to be x is equals to minus 1 and y is equals to 0. So we are done. We've done the first step. Let me just actually give it a heading. So the first step was to find the intercepts. So far it kind of, I make a rough sketch, it kind of looks like we have a point here, we have a point here, so most probably it's a minimum point. Anyhow, but we still need to actually find the critical points. So the turning point, since I haven't covered taking the derivative in these formal recorded lessons, we will do the completing square. So when I take 2 out as common, I have an x square plus 2x plus a 1, and then I can continue with what's 2 divided by 2 is just a 1, so 1 square minus 1 square plus 1, and then we have x plus 1 square minus 1 plus 1 is just a 0, and therefore we have a 2x plus 1 square. It seems like since 2 is greater than 0, it's a positive number, therefore we have a minimum point. And since this is just plus 0, right? So therefore the minimum point is a minus 1 and 0. So it turns out that our x, the x-intercept is the turning point in this question. So the x-intercept is the critical point. Sometimes you call this the vertex, and sometimes you call it the turning point. Sometimes it's known as the critical point. Sorry, I meant turning point, critical point, and vertex. Okay, so let's sketch this. Vertical axis, horizontal axis. We had a -1, -2, so we had 1 point here, and we had a 2. Okay, so 1 2 3 4 1 1 1 2 3 4. Okay, so these are the 2 points, and since it's the minimum point, so it should go like this. Yeah, and I'll label this as being my function fx. Okay, x-axis and the y-axis. Actually, I'm drawing fx and gx here, so the vertical axis represents these two functions. Oops, let me make this better. Okay, moving on to sketching the function gx. Okay, what was the function gx? This is the function. I'm going to copy paste it down. Remember, we have to do the same steps for this as well. Step number 1 is finding the intercepts. So for the x-intercept, we're going to take y is equals to a 0. So we have the equation as follows. We can use actually factorization, because I know 3 ones are 3, right? So the roots are quite easy to see here, and which are going to be a plus 3x minus x. Minus 3 is equals to a 0. X is equals to x plus a 3 minus 1, x plus a 3. If I take x plus 3 common, then the first expression gives us an x, second gives us a -1. So the x-intercepts, we are left with 2 intercepts. So one is going to be -3 and 0, and the other is a 1 and 0. So we've completed the x-intercept. The y-intercept is very easy, because you just have to take an x is equals to a 0, and when you take x is equals to 0, a 0 squared minus 2 multiplied by 0 minus 3. It's quite easy to see that you just have the y-intercept as 0 and -3. Okay, let's go on further. we need to do the completing square to find the vertex. So let's find the critical point. So most probably it's also going to be a negatively sorry, I meant a minimum point, because we just showed there's no point of intersection. No, actually there it could be like this also, and wouldn't be any point of intersection. Okay, so we'll just have to do the completing square. Okay, so y is equals to x square plus 2x minus 3. 2 divided by 2 is a 1, so I'm going to do a plus 1 square minus 1 square minus 3, x plus 1 whole square minus 4, right? So the coefficient next to this is greater than 0, therefore we have a minimum point, and the minimum point is a minus 1 and minus 4. So let's sketch this. A minus 1 minus 4. Okay, 1 2 3. Oops, I'm running out of space. I'll most probably can just move this up a bit. Yeah, let's just, okay, it's okay as long as we get this right. Okay, so 1 2 3 4, 1 2 3 4, 1 2 3 4, 1 2 3 4. Okay, so this is a minus 1, oops, minus 1, minus 2, minus 3, and a minus 4. So one critical point was minus 1 and minus 4, and we have intercepts as minus 3 0. Okay, so minus 3 and 0 over here, and a 1 0. So a 1 would be over here, a 1 and a 0. And what about the y-intercept? The y-intercept is a minus 3 right here. So if I make a sketch, oops, let me just make it a bit curvy and then try to make it go through the points that I wanted to go through. Yeah, that's fairly good diagram, and I can actually even extend it like this in order to show that these functions actually will not intersect. So this is gx. As you can see, there is no point of intersection, but there could be a point of intersection if, for instance, I move this graph like to the right or to the left or a bit down, or if I move this graph if I move it up, down, right, left, then there could be a potential point of intersection. So I think that's the going to be our takeaway from from the next part. Sorry, I added an unwanted graph. Okay, so part C says let C be a constant and this be a function. This basically looks like the function g, which is being moved by, it's either moved up or down. Find the values of C for which the graphs of f and h intersect. Okay, so it looks like this plus C. Okay, so we want to, in this question, we want to find a value of C for which we do have a valid point of intersection. So we have a x square plus 2x plus a 2 minus a c is equals to a 0. So the value of a is equals to 1, the value of b is equals to 2, and value of c is equals to 2 minus c is equals to 2 minus. Oh, this looks weird. But you know what I mean, right? The determinant is given as b squared minus 4ac. As long as it's greater than equals to 0, the discriminant, we have a valid solution in the xy plane. So b square is 2 square minus 4, a is a 1, the value of c is this. We need this to be greater than equals to 0. So we have a 4 minus 8 plus 4c greater than equals to 0, 4c minus 4 greater than equals to 0, 4c greater than equals to 4. So as long as c, the value of c is greater than equals to a 1, then you're going to have a point of intersection. So this ensures a valid point of intersection. Okay. The last question in this chapter is a sample examination question 2.3. It says the demand equation for a good is given as this and the supply is given as this, where P is the price and Q is the quantity. Sketch the supply and demand functions for P. Determine the equilibrium price and quantity. Okay, let's just divide the page into two parts so we can solve them side by side. We have the demand curve and then we have the supply curve. The supply curve looks easier because it's just a linear line, so we don't need a critical point, we just need the intercept. So whenever p is equals to 0, q plus 5 is going to be equals to 0, so q is equals to minus 5. And for this, let's put p on the horizontal axis and q on the vertical axis. So this one intercept is 0 and minus 5. And whenever q is equals to 0, we have a minus p plus 5 is equals to a 0. So we have a p is equals to a 5. So the other intercept, the p-intercept is a 5 and 0. So we can imagine this looking like this. We have a 5 here, we have a minus 5 here. So this is price and this is quantity, and this is what the quantity in terms of price for the supply curve looks like. Okay, let's sketch the demand curve now. The demand curve is q p plus 4 is equals to a 10. We can see that if p is equals to a 0, then 4q is equals to a 10. Therefore q is equals to a 10 by 4. So 2 2s are 4, 2 5s are 10, 2.5. Yeah, 2 2s are 4.5. Okay, and so we have this one intercept as p is equals to 0, q is equals to 2.5. However, when we take q is equals to 0, we have, this is not a possibility, because then you have a 0 multiplied by a p plus 4 is equals to a 10, and 0 actually is not equals to a 10, right? So hence there is no p-intercept. Okay, what else? since q is equals to 10 over p plus 4, you can't do the completing square to find the vertex, right? But what you can do is you can just observe the fact that how does quantity behave as price keeps increasing to infinity. It's like you have a 10 divided by an infinity, right? So in limiting behavior, it's just approaching 0. So, and what about the limit when p actually approaches a 0? And that's just going to be a 10 over a 4, which is the intercept that we had calculated. So this is a rough sketch that we can make. We know that the demand curve is approaching 0 like this as price approaches infinity. So the price is approaching infinity and this is slowly approaching 0. Quantity is approaching 0. And when price was approaching 0, quantity was approaching the intercept, which was a 2.5. And we had the supply curve, which looked like this. So this is the this is quantity demanded as a function of price. This is quantity supplied. And next they wanted us to find the point of intersection, which is just solving these two equations simultaneously. It's a fairly easy calculation. Let's do it. I just need to solve this equation simultaneously with the supply. Okay, this is equation 1, this is equation 2. So from equation 2 we can see that q is equals to p minus a 5, and you can just put in equation 1. So the q p plus 4 is equals to a 10 becomes a p minus 5, p plus 4 is equals to a 10, right? So let's open this up. You're going to get a p square plus 4p minus 5p. So that's just a minus p. Minus 5 fours are 20 is equals to a 10. So we have a p square minus p minus 30 is equals to a 0. 6 5s are, yeah, 5 6 are, so 6p plus 5p. I wonder if the voices of the birds are being recorded as well, because I'm sitting outdoors today, and I wonder yeah. P plus 5, p minus 6. So we have a p is equals to minus 5. Prices cannot be negative. P is equals to 6. Great. Yeah, this is the valid solution. So this is the equilibrium price, and the equilibrium quantity can be seen by from equation 2. So q star is just going to be p minus 5, p star minus 5, I think it was, yeah. So we have a 6 minus a 1, 6 minus 5. So the answer is a 1. So equilibrium price is a 6 and equilibrium quantity is a 1, which we can plot over here as 5 and 1. So that's the point of intersection. Yeah, and this brings about an end to the questions given in the EMFSS study guide chapter number 2. And in the next formal lesson in English, I will start solving the questions given in chapter 3 of the study guide. Take care and have a good day.